So, morning everyone and welcome to this lecture. This is Wave Optics lecture number 4. In the previous lecture, we had gone through what? We were looking at the interference and we had seen the different things in interference. We had seen what is fringe width. Do we remember fringe width?
Yes, sir.
Distance between any two consecutive maxima or between any two consecutive minima, lambda capital D by small d. We had also seen the angular fringe width. It is the angle that fringe subtends at the center point O. It is given by beta, the fringe width divided by d, or you can call it as lambda by small d. Moving ahead, we will now shift on what will happen if we have Young's double slit experiment with white light. What will happen if we have Young's double slit experiment with white light? What will happen if we have Young's double slit experiment with white light?
We cannot see the fringes, sir,
Why we cannot see fringes?
because it has 7 different wavelengths.
It has 7 different waves. Well done. Remember this, the central maxima in this case would be white, because whatever happens, all the wavelength at the center point, all the waves which may be of different wavelengths, but they will be having 0 part difference in the original scenario, and they will interfere constructively. Do you understand this? Because for the central maxima, if the point is at the center between the two slits, it doesn't matter what wavelength it is, both the waves coming from both the slits will travel equal distances and we will have constructive interference, and therefore you will have a central white fringe which will be bright. Do we understand this?
Yes, sir.
But slightly above or slightly below the position of central maxima, the fringes would be colored depending on the wavelength of the light, depending on the color of the light. For example, if P is a point on the screen, S2 minus S2P minus S1P is lambda violet by 2, then destructive interference will happen for violet light, and you will have destructive interference for the violet light. Do we understand this?
Yes, sir.
Similarly, if we have S2P minus S1P as lambda red by 4, we shall have destructive interference for red. Do we understand this?
Yes, sir.
And hence, we will have a lot of fringes of different colors. Some place red light may be interfering constructively, some place it may be interfering destructively. It can also happen that at a point where one light is interfering constructively, the other wavelength may interfere destructively. Do we understand this?
Yes, sir.
Please note this down. I'll give you a minute. So remember, in case of white light, the central maxima will be white. It might have red edges, and on the other side we will have different color bands, and again some may be interfering constructively, some may be interfering destructively. So you will have almost a uniform illumination, and as you said, you will not have any interference pattern as such. Do we understand this?
Yes, sir.
But central white fringe will be very bright because all the waves will be interfering there constructively. Everyone understands this?
Yes, sir.
Now, we can come to a special case where sometimes I have seen questions asked where they give you some point P and they make a hole there. They make a small hole there. And when they make a small hole there, then they ask, out of this hole, which all wavelengths will pass, and out of this hole, which of the wavelengths will not pass? Do you understand the question? They will use white light, two slits, and then somewhere on the screen they might give you a point or a hole, and they would ask you which wavelengths, which lights are going to interfere constructively or which lights are going to interfere destructively. But they will not ask you straightforward, they will ask you in a different way. They'll ask you which wavelength of light would be passing through this hole, or after this hole which wavelength of light would be visible. Do we understand what I'm saying?
Yes, sir.
In that case, what we have to do, you remember, whatever waves are interfering destructively, whatever waves are interfering destructively, they would be missing from that point. Do we understand this?
Yes, sir.
Whatever waves are interfering destructively, they would be missing from that point. That means for that, the path difference delta x, which is always equal to S2p minus S1p, that should be equal to 2n minus 1 lambda by 2. Do we understand this?
Yes, sir.
Everyone understands what I'm saying?
Yes, sir.
I have taken a very special case where this point P is directly in front of one of the slits. This question has come a couple of times in some of the previous JEEs. They have given you a point right in front of one of the slits and they ask you which waves are going to pass through that point, or after that point what wavelength would be visible. So basically they're asking you which waves are going to interfere destructively. Do we understand this?
Yes,
So
sir.
how do I find out which waves are going to be appearing after that point? We have to find out which waves are interfering destructively. We have to find out the path difference. I am not going to tell you how this path difference is calculated and what are the intricacies behind it. If this point is directly ahead, the wavelengths which are going to be missing after all these calculations, what you will find that the wavelength that would be missing will be d square upon 2n minus 1d. You understand how this 2n minus 1 has come?
Yes, sir.
This 2n minus 1 has come from here. Do we understand this?
Yes, sir.
And if I put the value of n as 1, 2, 3 and all that, all these wavelengths would be missing from that point. After that point, if I make a hole, these wavelengths would be missing from the spectrum. Do we understand this?
Yes, sir.
Just note it down. This question may come in advance, it may not come in JEE Main. And once again, we go through the conditions which are required for sustained interference. The phase difference must remain constant. Coherent sources, do we remember this?
Yes, sir.
Frequency and wavelength should be equal. Do we remember this?
Yes, sir.
Light must be monochromatic. We understand this?
Yes, sir.
Amplitudes must be equal. So the bright fringes will be very bright and the dark fringes will be absolutely dark. The source must be close to each other. If the sources are too far, fringe width becomes very small. If the fringe width becomes very small, our eyes will not be able to see the fringes. Do we understand this?
Yes, sir.
But if the fringe width becomes very large also, then that will also lead to your fringes not the intensity will decrease. So it should not be very small, it should not be very large. It should be somewhere, good size. Do we understand this?
Yes, sir.
I'll give you a minute to note this down if you want to. Then we come to this heading, which is known as optical path and geometrical path. Have you heard this? Optical path and geometrical path? What do you mean by optical path and what do you mean by geometrical path? Ah, if I take the example of light, let us say that this is vacuum. Oops, what has happened? It disappeared. Let us say that this is vacuum and light is traveling in vacuum. What is the speed of light in vacuum?
3 to 10
It travels with a speed c. Yes or no?
Yes.
It travels in vacuum. Let us say it travels a distance delta x in vacuum. Now, it is also traveling the same distance, let us say in a medium. The same distance it travels in a medium. Now, what is the speed of light in a medium? The speed of light in a medium is c divided by mu. Yes or no?
Yes, sir.
Where mu is known as the refractive index. Do we understand this?
Yes, sir.
Now, the speed of the light or the wavelength of the light in the medium is wavelength of light in vacuum divided by mu. Yes or no?
Yes, sir.
Now, when light travels a path delta x in a medium of refractive index mu, in the same time, how much distance it will travel in air or vacuum is known as your optical path. In very simple terms, if I say if light travels a path delta x in a medium of refractive index mu, then the optical path is equal to mu times delta x. So a distance delta x traveled by light in a medium in the same time, how much distance it will travel in vacuum, that distance is known as optical path. In very simple terms, if light is moving a distance x or delta x in a medium, the equivalent path in air is known as optical path, and the value of that optical path is always equal to mu times delta x. So that is what you got to remember. I'll give you a minute to write it down. No one is going to ask you the definition of optical path. You just have to remember a distance x traveled in a medium is equivalent to mu x in air. Do you understand this? That mu x is known as the optical path. Give you a minute to note this down. Here, this delta x, which is the actual distance traveled, will be known as the geometrical path. So this delta x will be known as the geometrical path, and this mu times delta x will be known as the optical path. Do we understand this?
Yes, sir.
For vacuum, geometrical path and optical path both are equal, but for a medium, geometrical path is delta x, optical path becomes mu times delta x. We understand this?
Yes, sir.
I'll give you a minute to note this down. Now, because of this optical path and geometrical path thing, if you place a slab of glass or mica, do you see this slab of glass or mica here?
Yes, sir.
Of thickness T, if you place any slab of glass, mica or any other material in front of any one of the slits, you can also place it in front of the other slit. If you place a slab in front of any one of the slits, the fringe pattern, because of this optical and geometrical path, gets shifted. If a film is put in path of the upper wave, upper slit, the fringe pattern will shift upwards. If you put it in front of the downward slit, it will shift downwards. If you put it in front of both of the slits, because of the upper slab, it will shift upwards. Because of the downward slab, it will shift downwards. Do we understand this?
Yes, sir.
The shift is what you need to remember. How much is the shift? The shift is given by this revolutionary formula, and you should never forget this, because most of the question may come from this part. The shift, how much is the shift in the fringes? It is d by d, capital D by d into mu minus 1 into t. What is mu and what is t?
Medium.
Mu is the refractive index and t is the thickness of the slab. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
If we talk about the number of fringes, if we talk about the number of fringes, it has shift. So number of fringes will be shift divided by the fringe width. Do we understand this? If we divide this fringe shift by the fringe width, you will get mu minus 1 times t divided by lambda. This is the number of fringes it has shift. So sometimes they will give you, it has the pattern has shift by 3 fringes. So the number of fringes that has shift would be 3. Do we understand this?
Yes, sir.
So this is what you need to note down. And I will put it on the screen. It just disappeared. So the number of fringes that has shifted is mu minus 1 times t divided by lambda. Do we understand this? Do we understand this?
Yes, sir.
Now, if you have one fringe, one film on the, or one slab in the upper slit, other slab in the lower slit, then the shift will be how much? Shift in case of two slabs. Number 1 in the upper slit, number 2 in the second slit. In that case, the shift will be d by d into mu 1 minus 1 t1 minus mu 2 minus 1 into t2. If mu 1 minus 1 into t1 is more, it will shift in the upper side. If mu 2 minus 1 into t2 is more, it will shift on the lower side. Do we understand this?
Yes, sir.
This question has come in JEE Advanced. Do we understand this?
Yes, sir.
Because of one film, it will shift by an amount d by d mu minus 1 t. Upper side, if the film is on the upper side, the slab is on the upper side, it will shift upwards. Downwards, it will shift downwards. If both, it will shift upwards as well as downwards. You will have to find out the net shift Give you a minute to note this down. Now let us start with some questions, and this is the first question that is coming up. The Young's double slit experiment using sodium light. 92 fringes are seen. If the given color, some other color is used, how many fringes would be seen? I give you a minute to think about this question. Yes, the option is?
D, sir.
The option is D. Remember, n1 lambda 1 is equal to n2 lambda 2. I have already told you that. Yes or no?
Yes, sir.
Remember that formula that I gave you yesterday? Yes or no?
Yes, sir.
N1 is 92, lambda 1 is 5898, lambda 2 is 5461. As soon as you see this, you even don't have to calculate. Lambda has decreased, so number of fringes has to increase. There's only one option which gives you that value, and that answer has to be 99. Do we understand this?
Yes.
Even if there were more options, you could have calculated it from n1 lambda 1 and n2 lambda 2. Calculating, you should be able to get the value of n2. Everyone understands this? Yes or no?
Yes, sir.
Okay. Let us now move on to the next question. Remember, any one of these questions is going to appear in your exam. This is the next one, my dear friends. In a Young's double slit experiment, an interference pattern is obtained on a screen by a light of wavelength 6000 Armstrong unit coming from coherent sources S1 and S2. At a certain point P on the screen, third dark fringe is formed. What is the path difference? It's as easy as it gets. Give you a minute to do this. Option B is the correct answer. Remember, for dark fringe, the path difference must be 2n minus 1 lambda by 2. Yes or no?
Yes, sir.
Third dark fringe n must be equal to 3. You just have to put 2 into 3 minus 1, 5. 5 by 2 into 6 into 10 raised to the power minus 10. And that should be 6000 into 10 raised to the power minus 10. And that should be your answer. It should be coming as 1.5 1.5 microns. Do we understand this? Yes or no?
Yes, sir.
Everyone gets this?
Yes, sir.
One of these questions is going to appear all of a sudden in your exam. Be prepared. I will try to cover as many questions as possible in today's class and tomorrow's class. This one is the next one. In a Young's double slit experiment, the slit separation is 1 mm. Remember, in almost 99% of the questions, in almost 99% of the question, in almost 99% of the question, in almost 99% of the question, the distance between the slits is given as 1 mm, and the distance of the slit from the source is given as 1 meter. I don't know why, because it just makes the question simple. It will always be in such a ratio that the ratio remains 1 by 2, 1 by 3, something of that nature. For a monochromatic light of wavelength 500 nanometer, what is the third distance? Third distance. Distance of third minima from the central maxima. Option B is correct. How did you get it?
Same formula, sir.
Third minima from the central minima, same formula you have to apply. Delta x 2n minus 1 lambda by 2. That is the path difference. You have to find out the position of y. Do we remember this y?
Yes, sir.
And that is this path difference multiplied by tan theta or something like that. Yes or no? Do we
Yes.
remember this formula? Again, you got the answer, but you don't know how did you get the answer. You have to find out the distance.
Sir, the formula is 2n minus 1 by 2 into lambda d by d.
Yes. The formula that I wrote was the formula of part difference. This is the formula of position of the fringes. Do we understand this? So
Yes.
here you will have to use this formula. Position of the fringe from the central maxima. Do we understand this?
Yes, sir.
So you just put this formula 2n minus 1 lambda d by d. Not this one. This is the formula for the part difference. The position of the fringe will be given by this revolutionary formula 2n minus 1 lambda capital D by 2D. You put the values, you get the answer, and you stay happy. Do we understand this?
Yes, sir.
Remember, any one of these questions is going to appear in your exam. Any one of these questions is going to appear in your exam. This one is the next one. Two slits are a distance of 1 mm, as I told you, 99% of the cases. Illuminated by a light of wavelength this. The interference fringes are observed on a screen page at a distance of 1 meter. I told you 99% cases. The distance between the third dark fringe and the fifth bright fringe. You have 2 minutes to give me the answer. Sir, it is option B and that is correct. I think I gave you that formula, yes or no? The
Yes.
distance between the two fringes. In any case, you can find out what? You can find out the position of the nth bright fringe. It is n lambda d by d, yes or no? You can find the distance of the mth dark fringe 2m minus 1 lambda d by 2d, yes or no? Which will be farther? The fifth bright fringe will be farther, yes or no?
Yes, sir.
So you can just subtract yn minus ym and the answer you will get will be the distance will be equal to, I think, n minus m plus half into lambda d by d. Yes or no? Yes or no?
Yes, sir.
You just put the values. N is equal to 5, m is equal to 3, lambda is 6.5 something. You don't have to put the values. D is 1, this is 1. You don't have to put the values because all of them are in the same unit. And you will end up with the correct answer. Everyone got this? Yes or no? No or yes?
Yes, sir.
Here is the next one in the line. Remember, any one of this question is going to appear in your exam. I keep on saying this repeatedly so that we'll deal with the question that has come in the exam tomorrow also. The slits in the young double slit experiment have equal widths and the source is placed symmetrically relative to the slits so that there is no part difference. The intensity at the central fringe is I naught. If one of the slits is closed, what is the intensity at this point? Remember when we had two sources interfering with the same intensity, the intensity at any point was given by 4 times I naught cos square phi by 2. Do we remember this?
Yes, sir.
Where I naught was the intensity of each source and phi was the phase difference between them. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Now, it is given that the intensity at the of the central fringe is I naught. So I will not use I naught. From here you can find out. Let me instead of I naught, let me use here some different things. Let me use as I slit cos square, otherwise it will create trouble because that is given as I naught. So I will write it as I 4 times I source cos square phi by 2. Now the at central maxima, what is the phase difference for the central maxima? The phase difference is 0, yes or no?
Yes, sir.
and this central bright fringe is given as I naught. So I naught will be equal to 4 times the intensity of the slides. That means intensity of one of the slides will be I naught by 4. Do we understand this?
Yes, sir.
Now, if one of the slits is closed, obviously there is going to be no interference. Nothing will happen. Whatever intensity is here, one slit, the same intensity would be there at the central maxima because there is no interference. So the answer will be I naught by 4. Do we understand this?
Yes, sir.
Do we understand this, everyone?
Yes, sir.
Okay, then that takes us to the next and the last question for today's class. We will continue to solve more questions because I know that if a question comes from this part, it will be from one of the questions that we are going to do. In our Young's double slit experiment, the angular width, I'm trying to cover each and everything that we have covered in terms of questions. The angular width of the fringes is 0.20 for sodium light. Lambda is given as 5890 Armstrong unit. In order to increase the angular width of the fringes by 10%, what is the change in the wavelength? So we know the angular fringe width theta was equal to lambda by d. Do we remember this? Here the distance between the slits is going to remain same, so I can write theta is directly proportional to lambda. Yes or no?
Yes, sir.
Theta 2 by theta 1 will be equal to lambda 2 by lambda 1. Yes or no?
Yes, sir.
Now theta 2 is 10% more than 0.2. So how much it will become? It will become 0.22. Yes or no? Divided by 0.2 will be equal to lambda 2 divided by 5890. Do we understand this?
Yes, sir.
So this will become how much? 0.1. 0.11. Yes or no?
Yes,
So
sir.
lambda 2 will become 0.11 times 5890. Yes or no?
Yes, sir.
Change in the wavelength will be lambda 2 minus lambda 1. If you subtract lambda 2 from lambda 1, what will happen? The answer is
Option A.
option A. I think I made a mistake. It should be 1.1, not 0.11. It should be 1.1, right?
Yes,
It should be
sir.
1.1, not 0.11. I make mistake like this. 1.1. This would be 1.1. So 1.1 minus 1, the answer would be option A. Do we understand this? If this question comes, please mark it correctly. We get this, everyone?
Yes, sir.
Everyone has understood what we have done in the class today?
Yes, sir.
Okay, we'll continue on with some of the questions we'll be doing questions from the previous years to make you understand what types of question comes. So the next class will be all about solving questions. I will give you time. You have time till tomorrow to go through all this formula. If you have a class in the evening, then we'll have a class in the evening and go through all these formulas so that you can solve maximum number of questions. I'll take leave. I'll see you tomorrow. Take care. Bye bye.
Thank you, sir.